Okay, so looking at mid-latitude cyclones on synoptic charts. This particular chart shows a number of mid-latitude cyclone features which we can identify immediately by the presence of fronts. So there is a big cold front, and there, and there. And of course the ones with the round symbols on are warm fronts. And there's another cold front over there. Right, so let's start off by looking at this one here. This is just a small, immature mid-latitude cyclone. You can imagine the polar front doing something like this. Just a small bend in the polar front, and that is where the vorticity that we spoke about previously develops, that you get a bit of rotation around that where the cold and the warm air start to mix, and that creates vorticity, which in turn creates the low pressure in the middle. That soon develops, provided that there's various other things going on in the upper air, will soon develop into something that looks more like this, a mature system. So in the mature system, you've got a very strong boundary between the cold and the warm air, the cold front, and ahead of that, the anticyclonic circulation around the high like that. That's the South Indian anticyclone, gives us a northwesterly flow ahead of the cold front. And then clockwise around the low, and this low is really just part of that. We've got a southwesterly wind behind the cold front. You'll notice that the isobars going across the warm front don't bend particularly strongly in this case, and nor do they in the other ones quite as strongly as they bend here. But that's because this whole system here is much more gentle than the cold front, which is pushing forward vigorously. Right, so if we remind ourselves then that this whole area here, behind the fronts, this is polar air. All of this air down here is polar air. And of course is our other front there. And then ahead of the fronts, all of this air is tropical air. So these mid-latitude cyclones develop along the polar front, which is the boundary between this polar and tropical air. Not always clearly defined, but nevertheless this boundary exists, and it's along this boundary that these mid-latitude cyclones develop. Right, the next thing that we need to understand about these systems is that as they grow from small little perturbations, that's disturbances in the polar front, to big storms like this, they are constantly moving from west to east. So this storm's direction is going to tend to be parallel to the isobars in that direction. Likewise, this one will be moving off in that direction, and these two over here in that direction. So that means that in terms of South African weather, that the front is going to come in. A few days ago it would have been here, and it would have had some influence on Cape Town's weather as it went past, and perhaps tomorrow, because of this high pressure here, it's going to go off in this direction. So this particular front, that would be its history, say over a 3-day period. And we need to be aware of that all the time, that as far as South African weather is concerned, we are interested in how this front goes across the country and what that effect is. And we will have a look at that on a different synoptic chart where we can see it more clearly. Other features that you see here, here we have a family of fronts. So a family of mid-latitude cyclones where there are more than one joined together by their respective cold and warm fronts. And you could probably actually consider this one there as part of that same family of fronts. and you can see how this may also have come very close to forming another one. So a family of fronts, and that clearly defines where in this case the polar front is. The fronts are greatly influenced by the position of the South Atlantic and South Indian anticyclones. In this case, the South Atlantic anticyclone is fairly far south, and it is blocking the movement of the fronts to the north, and you'll see there also is a bit of a ridge of high pressure like that, which is going to block the cold front from really influencing South Africa's weather. Right, let's look at the passage of a cold front across South Africa. Here is one approaching Cape Town. Here's Cape Town, and as you can see from the station model, there is a northwesterly wind blowing in that direction. So this is warm tropical air ahead of the front, and that's oceanic air. Warm oceanic air coming from the Atlantic Ocean, and we call that maritime air. Air that comes from the ocean is called maritime air, and it's part of the tropical air, so it's warm tropical maritime. So that's how we would describe that as an air mass, and we would call that MT air. So when there's tropical maritime air ahead of the front, what are you going to get? You're going to get a zone ahead of the front like this, where there are going to be cumulus clouds and perhaps some rain. Now as that front goes past Cape Town, what's going to happen? The low pressure is going to move in this direction, and that means that the front that was there is going to be now over here. Right, as the front approaches Cape Town, as I said, we have that northwest wind, and part of that northwest wind, you've got tropical maritime air ahead of the front, but then over here, going anti-clockwise around the high pressure, the extension of the South Indian anticyclone, here we've got wind blowing like this, and that there you can see is offshore, in this case not very strong, but that offshore wind is going to be a hot descending wind, and that hot descending wind on the South African escarpment is called the berg wind. Now what you quite often see associated with the berg wind, where this warm air is going out into cooler oceanic air, you get a weak little low pressure off the coast ahead of the cold front, and it can be on the south coast like that, or it might even be over here, because here as well the airflow is going to be offshore, and sometimes you do even have two of them. So these are called coastal lows, and it's just a shallow little feature, but does create quite a marked weather feature on the coast. If you're over here, it's the berg wind, hot and dry, and then it draws in cool moist ocean air, so if you're on this side of it, you get a sort of gusty wind blowing onshore over there. So that coastal low is a precursor, a signifier that the cold front is approaching. Once the front has produced prefrontal rain at Cape Town, then some interesting things happen. Right, so this chart shows what happens as the front goes beyond Cape Town. So there is Cape Town. Our previous cold front was over here, and this high pressure was over here somewhere, and now the front has moved to there. So let's have a look at what that means in terms of the weather associated with it. Well, first of all, the high pressure here, there would still be anti-clockwise circulation around the high like that, and we may once again have a bit of a berg wind ahead of the front over there in the region of the Mpumalanga Lowveld, northern KwaZulu-Natal. There is Durban. What's interesting is that while over here the rain occurred ahead of the front, over here you've got a different situation, because where here we had tropical maritime air, this air is continental, it's hot and dry. So ahead of the front here, we haven't got warm moist air, we've got warm dry air, and this is continental air, comes off the continent, continental tropical air, creating the berg wind ahead of the front, as we've already mentioned. So, what is the influence of the front then? Behind the front, and this is the real driver, the South Atlantic anticyclone is ridging in. That means it's pushing in this fashion. It's extending south of the country, and the anticyclonic circulation around that is going to be onshore, and you see those feathers pointing out to sea. And so you've got now cool, moist air, and look how far south it comes from. That this air is coming from 20 degrees south, this air is coming from 50 degrees south, so it's much colder. Look at the temperature here at Marion Island, 3 degrees. So this is very cold, and because it's coming off the ocean, it's moist air, so this is going to be maritime for off the ocean, and it's polar air. So you've got moist polar air, maritime polar air being blown onshore. Now the word we use for that onshore flow, or any wind in fact moving an air mass, is that it's advecting. Ad meaning to, advecting, you've heard of convecting, which is vertical movement, or advecting is horizontal movement. So just to write a sentence to describe what's happened here is that behind the cold front, the South Atlantic anticyclone has ridged in south of the country and is advecting maritime polar air onto the southern Cape Coast. And in that process, of course, here is the escarpment. You're going to get an onshore flow, an uplift, and you're going to get rain along that southern coast there. And that'll largely be orographic rain onto the mountains. Orographic rain, rain that is caused by mountains. Okay, and then that of course will then disappear off there, and then here comes the next cold front, and the cycle is repeated. Now one of the things that you notice about this is that this now is getting weaker, and it'll die out and disappear. Right, here we have a very interesting typical midwinter synoptic chart. Midwinter is June, as you can see over there, 20th of June in the year 2000. Now from what we said in the previous video, in the previous slide, here we have a cold front approaching Cape Town. Here is our extension of the South Indian anticyclone and creating an offshore berg wind flow. And where you've got an offshore berg wind flow, you're going to have warm, hot conditions on the southeast coast. Sometimes those coastal lows that develop as a result can develop on the southwest coast. So there is our coastal low resulting from the berg wind there, and you can see the conditions here. Typically the temperatures along here, bearing in mind that this is midwinter, might well get to be as high as 30 degrees or even higher along that coast, which is quite surprising considering it's midwinter. But this air is sinking, being compressed, it's dry and becomes hot. Now when that hot air flows out into the cooler sea air, it creates this low pressure, and then that creates a little mini circulation with the berg wind offshore, and then goes around like that and creates a little onshore flow. Now as the front approaches, this low moves off up the coast in that direction, and it is created specifically by the berg wind, which is created by the relatively steep pressure gradient between the high pressure here, the South Indian anticyclone, and the approaching mid-latitude cyclone and its cold front. So that's typical prefrontal conditions. Over here we have an interesting feature which we haven't yet discussed in detail. This here is called an occluded front. Now what has happened here is that the cold front was like this, and then the warm front would have been extending out from that, something like that, and the cold front has caught up. The cold front moves more quickly than the warm front, and so the cold front has caught up with the warm front until it's in that position, and this is called an occluded front, and we will draw some cross sections of that. Let me just spell it out for you, because this is a very good example. It's an occluded front, and notice we mark an occluded front with alternate sharp points and round symbols to indicate that the cold front is caught up with the warm front. The weather conditions associated with this, notice this is a particularly strong storm. Remember we said that the average pressure is 1013, and this is 940, or even lower at the center. So this is a very, very powerful storm, and although it's occluded, you will find that over this whole area here is liable to be cloud and precipitation. Right, that's a bit of an aside, and we'll come back and look at that later on in more detail. Okay, so going back then to our cold front approaching Cape Town, what is the weather going to be at Cape Town? Remember we said the tropical maritime air blowing in from the northwest in that direction. Tropical maritime air, and why it's written like that I'm not sure, because we always say tropical maritime rather than maritime tropical. And that northwesterly wind is going to bring rain as the cold air lifts up that warm moist air, and it's going to bring rain ahead of the front, something like that. Now this is not a particularly strong system, but you look here, you've got another low which is likely to join up with that, and then behind that, which is very interesting, you're going to have very cold air being advected. Remember we said advected is the word we use. Very cold air being advected from the south around that. So by the time these two fronts get to Cape Town, I think it's likely that they'll have joined together, and you're going to have a very strong cold front coming through Cape Town, and the rainy weather is going to give away to very cold, partly cloudy weather. Now the important thing here is that that northwest flow over there is going to change to southwest. So if you're sitting in Cape Town, you'll see there the symbol for the northerly flow. After the front has gone past, that is going to be southwest. So once the front is over here somewhere, you're going to have southwest. Here you've got northerly or northwesterly flow, and this change in wind direction like that is it's changing in an anti-clockwise direction, and when the wind changes in an anti-clockwise direction, we say the wind is backing. So the wind backs from northwest to southwest. So that's one of the features, that as the front goes past, the rain ahead of the front gives way to cold southwesterly air, cold polar maritime air, and the wind backs from northwest to southwest. If the wind is changing in the other direction, we say the wind is veering. So you need to know that behind the front the wind is going to back. So that is the typical Cape Town weather, and you need to be able to describe that. So just to recap, ahead of the front, berg winds, coastal low which can produce a little bit of cool onshore flow before the front gets there, then stormy weather ahead of the front, followed by cold, sometimes bitterly cold weather behind the front. Here we have an example, South Atlantic anticyclone ridging in behind the front. There's your ridge extending right across the south of the country. Now the impact of that is that it may well block these frontal systems over here. And this is an error here. Notice they haven't drawn in the little symbols that they should have on this front. Okay, so the ridge of high pressure, and what that's going to cause weather-wise is a little bit of onshore flow in the Mpumalanga Lowveld, and maybe a little bit of mist on the mountains like that. Otherwise, you'll see here the winds are weak, Notice that station model 18 degrees, so that's quite a lot cooler than the 30 degrees associated with the berg wind. And the fact that the feather here is in from the end of the symbol means that it's not 10 knots but 5 knots. So these are very weak winds, and they're typical of the center of the anticyclone. So you've got weak winds, probably clear weather. Well, there's the symbol, no cloud, and in fact in Cape Town there'll probably be a little bit of offshore flow here and quite warmish, and over the Mpumalanga escarpment perhaps a bit of mist. Notice again, this is the middle of winter, so the Highveld would be experiencing cool, dry weather associated with that, and nothing much more. Your mid-latitude cyclones have now gone off in this direction, and they're still showing as two separate ones. This is the day after the previous one, and we can see a bit of an occlusion developing there. Just to remind ourselves, there's the northwest flow ahead of the front, and then over here the polar flow coming from way far south, polar air. And this of course is tropical air. Notice the distance between the isobars in this area here, typical of the anticyclonic weather. Great distance between the isobars means calm weather and not a lot of rain. The air is stable. This advecting air coming in is not going to get over the escarpment. So what we're going to have in midwinter on the Highveld is going to be dry and probably quite warm weather, probably around about 20 degrees, and Cape Town similarly, because of the offshore flow around the anticyclone like that, although it's very weak offshore, probably have quite a pleasant warm day. But if you're sailing a boat down here, you're going to be dealing with very strong westerly winds. This is called the roaring 40s, where the winds pretty much blow all the time. Why is it called the roaring 40s? Because this is 40 degrees south there, 40 degrees south, and there's your line. And the yachtsmen who are racing from Cape Town to Australia like to get into these winds, although they're very, very powerful and the waves are huge, of course. They then race very fast towards Perth in Australia. Okay, that concludes our look at synoptic charts and mid-latitude cyclones.